This is Hot Science, with the week's top news in science, technology, and medicine. I'm Richard Clarke, and I host Hot Science. And welcome. So, hello there, guys. Good to see you.
I need to tell you, my friend Daryl has been sick for the past couple of weeks, so I'm sure that's why he's not here.
Yeah, I'm sorry that we have missed him. Anyway, the top stories that we're covering this week, it's the end of the year, and some of these are going to be summary stories. I'm muting you. I think, Bob, it's a noisy environment.
Right, go ahead and mute.
Okay. Anyway, so there are going to be a number of summary stories that we do this week. The top news is the 10 biggest science stories of the year as chosen by scientists. They should know, right? And in technology, really AI, I have this week a short story that I sent you all that is the return of crawling evil. And it's a Lovecraftian sci-fi story that was written and illustrated by robots. And in environmental, new food technologies could release 80% of the world's farmland back to nature. And I think that's one of the things that's going to be of vital importance in the rest of this century. In materials, I have another top 10 list, the material industry trends and innovation in 2020. In space, then there are from stunning images from James Webb Telescope to the first Mexican woman in space. Here are the top space stories in 2022. In biology, scientists now have solved the genetic mystery to how life on Earth began. And it turns out it's not with cellular life. We had to do things before the cells could start to develop. In anthropology, a story that Bob and I have been talking about, ancient humans may have sailed on the Mediterranean 450,000 years ago. So these were not Homo sapiens, these were our naval ancestors. And in health, just one kind of episodic story of the Chinese COVID epidemic from a Shanghai hospital that is warning that the tragic battle is beginning as COVID spreads. So that's what we have for this week. And let me start from the top, the 10 biggest stories as chosen by scientists. The first is the DART and Orion missions. So it's been busy in space this year. The DART is the double asteroid redirection test, and that was the ambitious project to slam a rocket into an asteroid to see how much we could move it out of its orbit. And once we know this, maybe we can find a way to protect Earth if we see another asteroid coming our way that's going to damage us. The other big space story, according to the scientists, was Orion. And this is really the start of the NASA operation to return people to the moon. And it's the first part of this mission, which is with the Orion capsule, the empty capsule designed to hold up to 6 people orbited around the moon. And that's the first part of the mission that they think is going to end up in 2025, hopefully, with a crew of astronauts landing on the moon for the first time in what, 40 years, 50 years? I am not calibrated properly on my moon flights.
It's 50 years, I think.
I think it was 50 years too. Okay, the next story, according to scientists, was the COVID boost to immune research. Vaccine technology has seen an unprecedented acceleration in innovation. And as our knowledge of immunology has increased, so has our capacity to innovate with vaccines. Two of the things they're talking about that were beyond reach as recently as a year ago that are currently being worked on is multivalent vaccines for both COVID and flu. The multivalent vaccines are ones that are effective against multiple variants. And so it's these kind of vaccines that are going to help us with the COVID pandemic. The other thing that's going to help us with the COVID pandemic is inhalable vaccines, and there's some of these already used in China. Then the third story was another AI story, and AI reveals new antibiotics. And so AI has transformed the field of molecular biology. And one application that they talked about is with dealing with antimicrobial resistance to vaccines, which is a global threat. And what they did with this AI system is they used AI tools to identify antimicrobial peptides that are encoded in the genetic sequence of microbes in the human gut. And they identified more than 2,300 potential antimicrobials, decided to synthesize more than 200, and ended up finding most of them, 181 of them, had antimicrobial capabilities, and more than half of them were entirely unknown to human beings. So a big step up in our ability to look at things like effective techniques to deal with resistant bacteria. The fourth item is early weather warnings. In 2022, we were able to see a hurricane hitting the coast of the US before it even formed out to sea. We could also visualize the Brisbane River in Australia spreading out to homes before a drop of rain had fallen. This advance warning gives much more of a chance to be able to react and protect ourselves. Then inclusive inroads. One of them is we made an advance in the treatment of sickle cell disease, and they identified a drug that was already developed to treat enzyme deficiencies. And I think an interesting part of it is that this breakthrough came from not looking at the red blood cells of people with this disease, but rather looking at the people themselves. What an idea for medical science. Look at the people to study the disease. It's funny that that is not an idea. Another story is about cellular biology. And, we think about what influences the cells as they grow and develop are biological or chemical factors, but mechanical forces the are just as critical. And these are the ability of cells to sense and respond to their mechanical environment. They've known this for some time, but they haven't been able to do anything with it because it has been hard to measure. They have seen early signs of diseases like cancer and Alzheimer's are often associated with changes in cell stiffness. They couldn't do anything to use that yet because they couldn't measure it. The measurements were invasive and damaging. And now they have found a new method to measure cell stiffness using an optical method that's non-damaging. And this will provide a powerful tool for early diagnosis of diseases like cancer, arterial sclerosis, and Alzheimer's. The next is quantum entanglement. Entangled, we had three pioneers of quantum information science were awarded the Nobel Prize in Physics for their contributions in understanding quantum entanglement. Understanding this is key to the development of quantum computers, among other things. And then in nature, this has been a huge moment this year for biodiversity with the COP15 conference and the beginnings of international agreements on biodiversity. And this is one thing that is needed and just getting started. And the last story that the scientists were excited about was with batteries. And one of the unappreciated stories of our time are the incredible rapid developments in battery technology. One of the big stories in battery technology this year was the development that is how to charge these energy dense batteries quickly in just a few minutes. If you can charge a car battery in 10 or 12 minutes, charging more frequently becomes much less of a problem. And this allows for smaller batteries and cheaper cars. There also has been huge progress in battery technologies based on sodium, which is cheap and abundant instead of expensive and relatively rare lithium. So that's what the scientists are most excited about this year. What about you guys? Is there any of the scientific stories that excite you? You're muted, Chad.
The merging of capacitor and battery technology is very interesting.
Yes.
Because capacitors have the ability to charge rapidly and discharge rapidly,
Right.
whereas whatever other batteries we have, that's not the case.
Right. How about you, Chad? You were getting ready to say something?
Yeah, I was. I thought one of the good, about the only good thing I can see that's come out of COVID has been the technology increases in vaccine. And this, I hope, will be helpful to us in the future. I was a little disappointed that there wasn't more detail in these 10 stories. I understand why. I mean, it is 10 stories, but more detail was needed in the battery technology, for
Right.
example. Just the differences between that and the antibiotic information, but I can see how the scientists would pick these 10 as being a big deal.
Well, again, it's interesting to me. I'll go ahead, please, Norman.
The more significant thing is China has developed the means to do away with their graying population.
You mean the COVID epidemic? Okay, they're gonna, with one governmental act, they're gonna reshape the population pyramid, huh?
Absolutely, retaining the people that are in productive years and removing those who are beyond their productive years.
Uh-huh.
A brilliant Chinese strategy.
I'm not sure that many people understand the wisdom of what you're saying, but I sure understand the perspective, and that's a real interesting twist, Norman.
It sure has validity because countries like China, Russia, France, Germany that are below reproduction means that there are fewer people to support the older people who are not productive.
That's right. That's right.
Although, on the other hand, the Chinese have done everything they possibly could to avoid COVID death. In fact, maybe to their detriment. And now that they're having to open up, the vaccine rates among the elderly are some of the lowest in the world. And I don't think that was the plan. I think that's just the way it worked out.
That's right.
I suspect the Chinese government has been changing the population now that they've liberated, gone away from lockdown, that they are diminishing the older population.
Okay, anyway, as I say, that's a very interesting viewpoint, and I appreciate it, Norman. And now let me continue with the stories. The next story we had was this story about AI writing and illustrating a sci-fi short story. So this was done with Chat GPT, which is OpenAI's new chat box. And some guys were wondering why not have it write some science fiction. So they gave the chat box a task to write a story in the tradition of H.P. Lovecraft, so it would have menacing elements within it. And so ChatGPT came up with a story of Sam, a Silicon Valley engineer and entrepreneur who accidentally unleashes an ancient evil while tinkering with AI, and he's then goes on a multi-year quest to stop the evil menace from taking over the world. And I read it. It's passable writing, but it's still not great science fiction. It more resembles B-list sci-fi pulp than anything that's going to win any award. But it's a story that is fiction and written by algorithm. And this is a new world for writing, I think. And it should be noted, they say, that this story was truly a collaboration between human and machine. ChatGPT wrote all the prose, but then the prose had to be edited. The chat box had an annoying habit of repeating itself, and all of that had to be edited out. So altogether, they had shorten about a dozen sentences and take some others out entirely, and only one need to be directly rewritten by a human. They also used DALI, which is the OpenAI's image generator, to make the illustration for each chapter. Let me see if I can show that to you. This was one of the illustrations. There were more than 10 illustrations that were done by the AI robot. Now, I sent all of you this morning the story so you could read through it if you had time and interest. One response I got from Andrew, who wasn't able to be here today, is he said their daughter is a librarian in Edmonton and tried GPT, asking it to write a story about senior citizens using the library. It instantly came back with a lengthy and credible story about old people using the library and developing a sense of community and all those things. And of course, the story was grammatically perfect. So here is a real life example of how somebody will be able to use this chat GPT to actually create useful content in like a website or a publication. Now, one of the things I'm sorry, go ahead, chat.
I was just going to say I read the story, and as a writer of short fiction, I found it pretty, like you say, pretty work. I could do better. But what I thought was kind of humorous was at the end, it had to have the typical American happy ending. Everybody's happy. Everybody gets what they want.
Yes. Now I do a lot of writing. It's not fiction though, but and I could see using something like a tool like that to write a first draft, give it my ideas and have it write a first draft and then use that as a basis for more work on it.
And you can claim it as your own.
Who knows?
I would anyway.
Right.
I was reading about some professor that had a paper that he suspected was written by a bot, and he couldn't quite figure out how to prove it or disprove it or anything. I think that's coming in our future.
And that's something that the academics know about and are worried about now. And not only the questions, how do you detect it? But also, what do you do about it?
Yeah, well, we used to pay people to write our papers. Now you can do it with a bot.
That's right.
Chad, we did that?
I I misspoke. I did never do that.
No, the thing I actually, when I went back to college, I went for one semester after high school and just wasn't ready to do the work because I never did any homework in high school except for math, which I did in my social studies class. While the teacher was saying everything 3 times, gave me time to do the math anyway. So I wasn't ready to actually do the work of college, and it was obvious after one semester. So I quit and joined the Air Force because I thought my problem was I needed to be older, and when I got out of the Air Force, I would be. So that worked successfully. Then I worked for IBM for 6 years. Then I used my GI Bill to go back to school. And when I went back then, I was ready. I had world experience. And what I loved the most was the writing. So I would not have hired the guy to do it because I wanted to do it myself.
This is when you're under pressure.
Oh, right. I understand. I understand. For that writing stuff, I was never under pressure because I started it as early as I could so I could give them revision 3 to turn in. So
Right, yeah.
I was more enthusiastic than most of the other kids in college. Anyway, so going on with the stories, next is our environmental story. And it turns out the basic problem for conservation at a global level is that food production and biodiversity and ecosystem garbage storage are all competing for the same land. And unless they figure out how to deal with this, then global conservation efforts are going to fail. It's that simple. And the good news is there are a number of new technologies that are being developed to make a system-wide revolution in how we produce our food. And they have studied what is being worked on, and they say this could meet the increased global food demands by a growing population that is eating more protein on less than 20% of the world's existing farmland. So we can provide all the food that the growing world needs on just 20% of the land. Of course, with the land now, about 4/5 of the land is used for food production related to meat and dairy. The global meat production or consumption has increased by more than 50% in the last 20 years. This is one result of increased wealth getting down to more people in the world, and it's set to double again in this century. So unless these things are solved, we're in real problem. And it looks like what they're calling cellular agriculture looks like it provides the kind of alternative. This is what they call lab grown food, where they're growing animal products from real animal cells. And so, if to imagine what this looks like, think of a brewery or a cheese factory, and instead of barley or milk as inputs, you use what you need to be able to brew the next piece of chicken or steak from the cells. So that's one approach. Another approach is microbial protein production, where bacteria use solar energy to convert carbon dioxide and nitrogen into other nutrients like carbohydrates and protein. This could generate as much protein as soybeans do now, but in just 7% of the area. It's also possible to use this same technique to generate sugars and carbohydrates on just a tiny fraction of the area that is presently consumed. And if you do this, what used to be farmland, you can turn into nature preserves, areas to restore your biodiversity, to store carbon. And so there are many benefits from this. The problem still is that it's going to require a lot of political will and a cultural acceptance of these new forms of food. I suspect cultural acceptance of new foods is actually the biggest problem, because foods are so ingrained in our culture. You know, when you think about things like we've just gone through holiday meals, these are traditional foods that are just kind of wired into our expectation of life, and it's tough to change those. Anyway, what do you guys think about alternative food production? Are you ready to eat cell-grown meat or brewed protein?
Absolutely ready, but the energy consumption for lab-grown meats is extraordinary. So it's something that works well, perhaps in the Middle East or other equatorial areas, but not throughout the world. The energy consumption is just too great.
It's still an early place in the process, though, and they haven't scaled it up. And part of scaling it up is dealing with the energy consumption in terms of other resources, water and nutritional elements. It uses something like 10% of the hoof-grown beef.
Environmentally far better, but the energy consumption for lab-grown meats is astronomical.
Absolutely. My brother owns a cattle ranch in northern Utah, and I'll ask him what he thinks about this.
Okay. I'd be interested in hearing. Certainly, it's got to be something that he's thought about it. And again, there are two sides of it. One side of it is the lab grown meat, and the other side is using bacteria and what is essentially fermentation processes to turn sunlight and carbon and nitrogen into things like protein. And that uh, uses less energy and significantly less resources as well.
But Chad, there are feeds that vary tremendously the methane output of cattle. Are those widely adopted, or is that just something that's mandated in California a couple years hence?
I don't know if they have production of that algae up high enough to be able to use it all throughout the cattle raising world, though.
It's just seaweed.
Right, a particular kind of seaweed. And so I have read elsewhere that in Australia, they just got the biggest the world's biggest farm of that kind of seaweed started.
Because California has mandated the reduction of methane emission from cattle by 50%, and I forget what the timeline is.
Right, right,
It's
and
something that's eminently doable.
right. Just got to change their feed. Okay, the next story is another roundup, and this is a roundup in materials of the material industry trends for 2022. And this was done based on an analysis of about 2,500 global startups and scale ups. And so looking at them for what they are doing, the top trend is in sustainable materials. Companies in the construction business, automotive, packaging, and manufacturing sectors are looking for ways to use sustainable materials to lower their carbon footprint. So there are a lot of these materials that are being developed. These sustainable materials also allow for the implementation of a circular economy, which is one of the things that's key for the future. Another item is smart materials. These are materials that have programmable properties that behave in different ways in response to environmental stimuli. One example that I have heard of these smart materials is a kind of building block that under normal circumstances has its strength going up like you would need to support a building, but when subjected to the sideways vibrations of an earthquake, stiffens to provide increased earthquake resistance. So smart materials are one of the things that are coming. Then, of course, another enormous area is nanotechnology, which are these nanoscale materials. The first thing is that nanoscale, the properties are different than they are as bulk materials. And they're using that now, making nanofibers and nanotubes and quantum dots and things like this that are providing a wide range of improved capabilities. Another area is additive manufacturing. That's now become the formal name for 3D printing. And one of the things they're doing with additive manufacturing is they're trying to evolve beyond traditional thermoplastics and use material that have greater flexibility and functionality while producing less waste. So that obviously is an area. We also hear about other 3D printing materials that are being developed that are, for example, conductors. So you can print a functioning electronic circuit complete with traces and conductors that you need to add the components like the microprocessors. Then another material tendency is light weighting, which is looking for ways to diminish weight and provide better fuel efficiency and handling. And this drives research into materials like aluminum, magnesium, titanium, and as well as high strength plastics and carbon fiber. So these are all things that we can see make sense. Then uh, AI comes to materials in the terms of material informatics, and today's big companies employ a data-driven approach to material and use AI to accelerate their research and development processes. Then one more trend is with advanced composites. These are composite or hybrid materials that use layers of different materials, and you use them trying to improve performance as well as reducing costs. And they're innovating with resins and fibers and substrates and matrices and finishes to develop custom components. And this is a wide area of materials research. Then, of course, there's graphene and 2D materials. With graphene now, there are a number of industrial sectors using graphene already, including electronic displays, supercapacitors, automotive, construction, paints, and plastic manufacturing. And then there are a number of new 2D materials that are still under development. One of them is germanium out of germanium, silicene out of silicon, statine, I'm not sure what that's from, and phosphorine are other materials that are in development and will provide the next generation of 2D materials with capabilities that are beyond anything we know now. And then finally, there is surface engineering. If an item is exposed to continuous wear and tear, corrosion, UV rays, and other harmful factors, these surfaces require coatings that improve the durability. And that's one area that a lot of work is being done in. And in the area of COVID, then surface engineers are working to make antimicrobials to put on surfaces to suppress various viruses like the COVID virus. So materials is not a very dramatic area to most people, but it's one area where an immense amount of work is being done. Any comments from you guys? Then let me move on. And the next is basically the stories, big stories from space. And the biggest story from space this year was the web. And here's one of the early images that was released from NASA. This was released on July 12th, and it shows the view of a star surrounded by gas from another star and shows amazing detail. Here's another picture of Stefan's quintet. I think when we see that, that resolves to one star. Here is another, I think, interesting-ish image, and these are two stars in the Wolf Rayet, and they produce shells of dust every 8 years that looks like rings. And this image, you can see these rings illustrated from the Webb telescope. So that's one range of the big stories. Another story that is big in science or space is we're getting more female astronauts. And here is the first ever Mexican born American to fly in space. And so what's her name? Katya something that I can't pronounce. Anyway, so it's space is getting explored now, not just by men, but by actual people and women and Mexicans. Another one I didn't show the picture of was the first Native American going into space. Now, the other big space story was the Artemis moon rocket lifting off from Cape Canaveral. That's something we're going to continue to see coverage of for the next several years as the moon mission proceeds. Okay, so turning to biology, then the scientists feel like they've solved the mystery of how life on Earth began. And the missing link turns out not to be a fossil, but some tiny self-replicating globule that happened before the development of DNA and cells and things like this. If DNA and cells developed, there had to be something before them, and the scientists couldn't figure out how all this stuff started. And now this kind of chemical evolution was first proposed in the 1920s as the first way that life was going to start originating, making simple small molecules. But after the development, discovery of DNA, then DNA has been the thing that they've been looking at, and their main thing they were studying for the development of life is called the RNA world hypothesis, where they really looked only at self-replicating genetic material. And so anyways, scientists studied this missing link between chemistry and biology and the origin of life, and asking the question, how did free-form chemicals in early life become life? When they looked at it, one big issue was proliferation. That is, how did these elements spontaneously produce the polymers and the self-assembly that is needed to begin to make life? And so the scientists designed and synthesized a new prebiotic monomer from amino acid derivatives as the precursor to the self-assembly of primitive cells. And they found that when this was added to room temperature water at normal atmospheric pressure, the amino acid derivatives condensed and arranged themselves into peptides, which spontaneously formed droplets. So you're having the beginnings of the thing that will become life, and the droplets grew in size when fed with more amino acids, and particularly the droplets could concentrate nucleic acids, which are the beginnings of the genetic material. And in fact, those droplets that had these nucleic acids within it were more robust, more able to survive against external stimuli. So there was an advantage for the droplets having this nucleic acid. So this droplet-based protocol could have served as the link between chemistry and biology in the development of life. Here I have a drawing. Let me show it to you and see if it makes any sense. So here we have the amino acids combining and forming the peptide and then auto-assembling into a droplet, and the droplet, when you get some nutrients, then reproduces himself, and then with nutrients are enriched by and become macromolecules, and then become this self-maintaining droplet. And so this is a chemical idea of what chemical processes could have led to the beginning of life. Now, I'm sorry Bob isn't here, because the next story was one that he and I are both very interested in. It turns out that pre-humans may have worked out how to sail across the sea as far back as about 500,000 years ago, or maybe 1,000,000 years ago. They did a new analysis of shorelines 500,000 years ago. And one of the things that has troubled them for a long time is that in the Aegean Islands off Greece, there are these human remains, and they've been inhabited for a long time, potentially as early as 476,000 years ago. And they didn't know how the humans got there. They thought maybe the rising and lowering of oceans, that there was some time where there was a land bridge. But the scientists carefully studied the environment and the lakes and the Mediterranean during this period, and they did find that at the lowest point in the last 450,000 years ago, the sea level was about 700 feet lower than it is today. But even at the lowest point, there were still several kilometers separation between the mainland and these islands. So the only way the guys could have gotten there is by boats. And it turns out further that this was not the earliest sea crossing. They think in Indonesia and the Philippines, between 700,000 and 1,000,000 years ago, early pre-humans got there somehow, and they were just islands, or it had to be boats. So it looks like boats have been part of the human and pre-human technology for maybe up to 1,000,000 years. And this really changes the idea of how these early humans and pre-humans got around, because if they could sail, then it starts providing different explanations for how did people get there. certainly it makes sense with the islands in the South Pacific because there are people there from a long time. It may even be an explanation of how they got to places like South America in the oldest population. So boats are the way. No sailors in the crowd. Okay. Now, the last story I had talked to you about was a kind of episodic COVID in China story. This is from Shanghai, and a Shanghai hospital has told its staff to prepare for a tragic battle with COVID. This was on December 22nd, and they said they expect half of the city's 25 million people will get infected in the next couple of weeks before the year end while the virus sweeps through China. And the Shanghai hospital expects more than 5 million positives in the city. There are cities on their own that are starting to distribute free anti-fever drugs. And while this is happening, the Chinese government, of course, is reporting things like no COVID deaths for the second consecutive day, even while funeral parlor workers say that they're busier than they have ever been. And so official case figures now are unreliable for what is happening in China, but it really looks massive. And people who are studying this say infections in China are likely to be more than 1 million a day, with deaths of more than 5,000 a day. And so when you look in cities like Shanghai now, even though the restrictions are over, many areas of Shanghai were almost as deserted as they were during the peak of the restrictions. And companies are saying, all our employees are sick. And like Chad was talking about, China's vaccination rate is about 90%, but the rate for adults who have received booster shots is below 60% and about 40% for people age 80 and over. And, the hospital says at the time the article was written a week ago, they said already their emergency department was 4 times busier than usual. And mainly these patients are all elderly people with underlying diseases. The Chinese U-turn in their policy about COVID left a fragile health system unprepared, and so everybody is still scrambling. And we haven't heard the real story yet. I don't know how long it will take to get the real story out. I know Norman has talked a lot about this.
The Chinese policy on COVID is diminishing the aging population, bringing back a younger population that's more supportable in the economy.
Is that something you've read somewhere?
Read, heard about, and makes sense. It's the older Chinese that are dying.
Well, why did they spend all this time and effort trying to protect the elderly.
Who knows whether that was actually the case? The information coming out of China is often suspect.
I'm more inclined to believe the best of people.
But still, there's no doubt in China that this freedom from lockdown is decimating the older people.
Right. That's certainly, nobody can argue with that.
Nobody can argue that, but but they were forced to do it because of the population was uprising, and there was a lot of unintended consequences from trying to protect their citizens from COVID. Zero COVID was a goal that was never going to happen. So,
And certainly zero COVID had fairly disastrous impacts on the Chinese economy.
right. I don't think they did all this to try to reduce the elderly population.
Anyway,
The freedom from the lockdown is impacting the elderly at a much higher rate.
and that's certainly true.
Absolutely, but the Chinese government has been forced to do this. They didn't do this by choice.
Anyway, it's been good talking to you two guys, and thank you for joining me. And we'll do it again next week, and maybe we'll have a few more of our regulars with us. So anyway, see you next week. And if I don't see you between now and then, have a happy new year. Feliz años.
Same to you, Richard. Thank you.
All right, adios.